So this may come as a surprise, but section 7 of this chapter is probably the easiest section of the whole chapter. And when it comes to something that sounds as grand as the fundamental theorem of algebra, you might be confused why something so important would be so simple. But you have on the sheet in front of you that the fundamental theorem of algebra tells us that an nth degree polynomial has n zeros. So whatever the degree of the polynomial is how many zeros or how many solutions that polynomial would have. And we've seen that with lines. How many places does a line go through the x-axis? It can only hit the x-axis in one place, and the degree of a line is 1 because it's x to the first. Or a quadratic with a parabola. It's x squared, its degree is 2, and how many places can it go through the x-axis? It'll hit it in 2 places. Or how many solutions does a quadratic have? Well, when we factor it, we always get 2 factors, and so there's 2 zeros or solutions. So whatever the degree of a polynomial is how many zeros that polynomial could have. So in this section, for these problems, you're not even finding the zeros, you're just determining how many there are. So on these examples, if we have a function that begins with 4x squared, and that's the degree, if they're not trying to trick us and there's actually like a 5x to the 5th over here, assuming that it's written greatest to smallest when it comes to powers, if this is 4x squared, then this has 2 zeros. And you might say, well, what about when we have, if it factors to x minus 3, x minus 3, then 3 is the only solution, or the only zero. We count a solution for as many times as it's repeated. So we had x minus 3 as a factor twice. So we count it as a solution twice. Okay. So you just look at the degree, and that tells you how many zeros that polynomial might have. So if we have f of x equals negative 20 x to the 7th, if that's the highest power, then we could have 7 zeros. And just for fun, if we have pi x to the 123rd plus a whole bunch of other terms, and it's a polynomial, then we could have 123 zeros. Easy as that. And that's the fundamental theorem of algebra.